Hello, my name is Sahil Kumar, roll number 2201CS60, and today I'll be demonstrating my assignment 9. And the name of the assignment 9 is cryptographic for big data security, especially focusing on HDFS layer encryption using envelope encryption. Let's start with the central component, the KMS client. This simulates an isolated key management server. It holds our master key or KE keys, which are 256-bit AES GCM keys. The, the important functionality here is the generate DEK method to create unique data encryption keys for each HDFS block and encrypt DEK, which cryptographically wrap these DEKs using the master key before they are sorted. Now the encryption engine. Moving down to the HDFS encryption class, this represents our core encryption engine. In the encrypt block function for every data chunk, it generates a DEK, encrypts the payload using hardware's accelerated AES 256 GCM and securely store the wrapped DEK in a metadata store for decryption on road. You'll see in the decrypt block method that I've implemented an LRU cache. This ensures we don't have to endlessly query the KMS during sequential routes, drastically improving performance. Now let's go to the finally the rear run encryption pipeline physically connects to our Hadoop cluster via web SDFs. It provisions of 500 MB data set is seeded especially for me, uploads it to HDFS and incrementally retrieves it into 128 MB block chunks to enforce encryption natively. This exactly replicate a production big data ingestion pipeline. Now let's run the code and see how it's working. So Python is DFS encryption.py. Now it's running. Now here you can see the system initially authenticate as Sahil 2201 CS60 and upload a precisely allocated 500 MB data into a HDFS namespace. Here we can see the envelope encryption running live at 9870 port. The data set is segmented into four blocks of 128 MB HDFS chunk size. For every single block, a completely unique DEK is generated. Notice the execution time. It's only take about 40 milliseconds to encrypt a 128 MB block natively, facing a minimal 60 byte GCM authentication tag overhead. You can see the encryption for first block, and it is taking 42.14 encryption time, and overhead is 16 bytes. Similarly for second block, and similarly for all the four block. Now at the end of the run, our total throughput reaches nearly 1.84 gigabytes per second. Looking at the key management module, you can see our isolated secure architecture. We have four native data keys that are in cryptographically wrapped and protected by our active master key, the 202501 keys. These are the master keys. When a user trigger an HDFS read, the system faces the encrypted DEK from metadata, seamlessly unwrapped it via the hardware KMS and the caching algorithm we mapped out in the code. The decryption overhead is phenomenally fast, around 22 milliseconds, all while validating the true AES-GCM authentication. These are the reading files, and these are the decryption process. 5 decryption process. Here you can see the decryption DK using keys. It takes 2.14 millisecond, and decryption block data it will take 19.88 second, and the performance or decryption overhead time is 22.08 millisecond. Lastly, strict compliance require key rotation. On the fly, our KMS generate a brand new 225.02 master key. These are the new key that are generated. Because of our strict envelope design, it only needs to dynamically re-encrypt the four tiny metadata decades. It completely rotates the cluster security without needing to touch half a gigabytes of raw data. The rotation finishes in less than 100 seconds, and you can see the time it has taken. And that's conclude my demonstration. Thank you.